In this video, we will discuss the different types of chemical bonds that are used to make compounds. Compounds and molecules are composed of atoms that are held together via chemical bonds. These bonds are the result of the attractions between the charged particles that make up the atoms. Those charged particles, again, being the electrons and the protons. Neutrons, as you will recall, are non-charged particles. So the things that are causing the attractive force, which we will call chemical bonds, are the protons in the nucleus of one atom attracting the electrons on a different atom. The chemical bonds are classified into one of three types based on the elements that are comprised of the bond and the level of sharing of the electrons. On one end of the spectrum, we have ionic bonds. These are bonds in which the electrons spend virtually all of their time on one of the two atoms that make up a bond. Covalent bonds, on the other hand, are ones in which there is a near equal sharing of the electrons between the two atoms in a chemical bond. The last category of chemical bonds are metallic, which is not really discussed in your textbook and is generally left for later classes in chemistry. We will not be discussing metallic bonds in this course. Let us now compare and contrast the two different types of chemical bonds that we will be considering in this class, ionic bonds and covalent bonds. And let's look to see the difference in characteristics of those bonds and the effect those bonds have on the characteristics of the molecules that they make. First, looking at ionic bonds. If a compound has an ionic bond, in that bond the electrons are completely transferred from one atom to the other. So an example of this would be sodium chloride, which is standard table salt. In the case of sodium chloride, the chlorine atom accepts the electron. The electron is completely transferred from a sodium atom to a chlorine atom, typically adjacent. In molecules that have ionic bonds, there is no defined molecule. It is impossible to tell which sodium atom transferred which electron to which chlorine atom, because they are all touching. Ionic bonds are very strong, and it is the strength of these bonds which makes the compounds brittle in the solid form. Because the bonds that are holding the solid together are very strong, when you strike them, they do not deform. Instead, you get a brittle compound. Also, because the molecules that are holding the compounds together are very strong, you end up with a high melting point. It is very difficult to get these molecules into the liquid phase. Molecules with covalent bonds, on the other hand, in the case of molecules with covalent bonds, in a covalent bond, the electrons are shared in the bond. There are defined molecules. You can clearly tell which atoms are sharing the electrons with the other atoms. These form weaker types of bonds as compared to the much stronger ionic bonds. The compounds and molecules that are comprised of covalent bonds in the solid form tend to be malleable, although some of them can be a little bit brittle, though less brittle than the ionic bonded compounds. Molecules that only have covalent bonds tend to have low melting points. That's because the thing that are holding the molecules together are much weaker than the ionic bonds that are holding molecules with ionic bonds together. We can actually look at the periodic table and determine whether a bond is going to be ionic or covalent. In the case of ionic bonds, these again are the ones where electrons are completely transferred from one atom to another. The way that occurs is because one of the atoms pulls the electrons more tightly than the other. So the electron affinity is much higher for one of the atoms than the other. A quick way of determining whether something is going to be an ionic or covalent bond is looking at where the two atoms that make up a bond are located. If one atom is a metal and the other is a nonmetal, so if one atom is located here, excluding hydrogen, so lithium down in this section here, so in the metals, and the other atom is a hydrogen or something over here, so that would be considered the nonmetals. If a bond comprises one atom from the metal section and one atom from the non-metal section, then it will be an ionic bond. And that's because metals readily give up an electron, and non-metals have a high affinity for electrons, meaning that they will tightly hold on to those electrons. When a metal interacts with a non-metal, it will transfer one or more of its electrons to the non-metal. Metal atoms then become what we call cations. These are positively charged ions, and the non-metal atoms become anions. So again, the way that we will determine if something is an ionic bond is it needs to have one of the atoms in the bond coming from the metal section and one coming from the non-metal section. Because the electron in an ionic bond is completely transferred from one atom to another, the opposite charged ions attract one another via electrostatic force in the form of an ionic bond. So because one of the atoms in this, if we're looking again at sodium chloride, because the sodium atom has a +1 charge and the chloride atom has a -1 charge, all of the sodium atoms are going to be attracted to all of the chloride atoms. So if we look at this sodium atom right here, it is being attracted to all of the chloride atoms around it. So it's not just the chloride to the right or to the left, it's the chloride to the right, left, forward, behind, up, and down that it is being attracted to. The result is an ionic compound. Ionic compounds are any compound or molecule that has an ionic bond. In the solid phase, these ionic compounds will be composed of a lattice structure, which is a regular three-dimensional array of alternating cations and anions in a regular pattern, in which each cation is interacting with all of the anions that surround it, and all of the anions are interacting with all of the cations that surround them. Because all the atoms are interacting with each other, we get very strong bonds. Covalent bonds, on the other hand, occur when you have two nonmetals that are being bonded together. This is because they involve a more equal sharing of the electrons. So if you have two nonmetals, hydrogen is included in this consideration. So hydrogen and or anything else in the nonmetal category, when you have two of those atoms that are bonded together, it is called a covalent bond. And that's because each one of these have a similar pull to the electrons, and that's because each one of these has a similar pull on the electrons. And so because the pull is similar, there is a more equal sharing of the electron in a bond. When a nonmetal bonds with another nonmetal, neither atom is able to transfer the electron to the other. Instead, the bonding atoms share some of their electrons. The majority of molecules that we will interact with are made from covalent bonds. Hence, they are often referred to as molecular compounds. Molecular compounds are composed of atoms that are covalently bound together. The difference between a molecular compound and an ionic compound is that in a molecular compound, you can clearly tell which atoms are bound together. In the case of an ionic compound, you cannot tell which electrons came from which atom.